Hello friends, welcome to Bindu Dhadwal chemistry lessons. Today's topic is writing Lewis structures for molecules. To write the Lewis structure for a molecule, you follow the various steps. We will do the steps first so that you understand the technique, and then we are going to write the Lewis structures. First step is calculate the total number of electrons required for writing the structure by adding the valence electrons of the combining atoms. For example, if the molecule is methane, so in the outermost shell of carbon, the valence electrons are 4. Configuration of carbon 1s2, 2s2, 2p2. So in the second shell there are 4 electrons. Similarly, in the valence shell for hydrogen there are 1 electron in the first shell, but there are 4 hydrogen atoms, so total valence electrons in hydrogen are 4. So total valence electrons become 4 plus 4 is equal to 8. So we will distribute 8 electrons in different bonds. For anions, each negative charge means addition of an electron onto the valence electrons, and for cation, each positive charge means subtraction of 1 electron from the valence electron. If there is a negative charge on the molecule or anion, that means the total valence electrons will be the sum of valence electron plus the negative charge that is there. Similarly, for cation, you decrease that much number from the total number of valence electrons. Step 3. Knowing the chemical symbols of combining atoms and guessing the skeletal structure of the compound, distribute the total number of electrons as bonding shared pairs between the atoms in the proportion to the total bonds. For methane, you know the symbol of carbon and hydrogen, and the least electropositive atom is placed in the center. Hydrogens are always placed on the terminal position, and 8 electrons are distributed. A bond is formed between carbon and hydrogen. After distributing the shared pair of electrons for single bonds, remaining electron pairs are used either for multiple bonds or lone pairs, and the basic requirement is that each bonded atom gets an octet of electrons. So while we place the electrons, we also make sure that each atom gets its octet. For example, for carbon monoxide, let us first calculate the number of valence electrons. So for carbon, the number of valence electrons are 4. For oxygen, 6. Configuration of oxygen is 2, 6. So 6 in the outermost shell, and then the total sum of the electrons is 10. Now you have to distribute 10 electrons between the carbon and oxygen atoms in such a way that both the atoms have a complete octet. The first step is to put 2 electrons or single bond between the atoms and then try to complete the octet. We tried to do this. We have to distribute 10 electrons, 2 for this bond, 8 electrons. So in order to complete octet for oxygen, we put 6 electrons and remaining 2 with carbon. This completes the octet of oxygen, 6 plus 2, 8 electron. But the octet for carbon is incomplete. There are only 2 plus 2, 4 electrons for carbon. So this structure is not the correct structure. So I have put the cross over here. Now, in order to have a correct structure, 4 more electrons were needed for carbon. So what we do is, we will place 4 electrons in sharing in addition to this one. So 1 bond plus 4 more electron means 2 more bonds. So 3 bonds here, that means 6 electrons, and remaining out of 10 you have placed 6 electrons here, remaining 4, 2 each. So this gets its octet, 6 plus 2, 8 electrons, and this oxygen also gets its octet, 6 plus 2, 8 electrons. Now the problem over here, we have distributed the electrons correctly, but oxygen can show maximum covalency of 2 bonds. Here there are 3 bonds, so that means that there is a positive charge over here and a negative charge over here. So this is the structure for carbon. Overall the molecule is neutral because negative and positive neutralize. Formic acid. Let's calculate the total number of valence electron. 1 for hydrogen, 4 for carbon, 6 for oxygen, again 6 and 1. So the total becomes 18. We have to place the skeletal structure. We know the formula is HCOOH. So we place it in this manner, HCOOH. Hydrogen's duplet is completed. So this is the Lewis structure for formic acid. Another example, nitrite ion. Now there is a negative charge on nitrite ion. So let us calculate the total valence electrons. 5 for nitrogen, and so 2 into 6. This is 12 plus 5, 17. And 1 electron is added for 1 negative charge. So total electrons 18 are to be distributed. So nitrogen is less electronegative, so it will be placed in the center. First we place 2 electrons each between the atoms. But by doing this, by trying to complete the octet, we see that the octet for nitrogen is not complete. So this structure is not correct. So we have to place 4 electrons in one of the oxygen atom, double bond. And by placing the double bond, the octet of all the atoms is completed, and also the 18 electrons are distributed completely. Next is hydrogen peroxide, H2O2. The total valence electron you can now calculate. 2 plus 12, 14. So oxygen is placed in the center, hydrogen on the terminal position, putting 2 electrons between the atoms and completing the octet. You get HOOH. So oxygen 2, 4, 6, 8. Similarly, the other oxygen also has its 8 electrons, and hydrogens have their duplet complete. For NF3, this is the proposed structure. You place N in the center, F on the 3 sides, single bond between each atoms, and complete the octet by placing the electrons. Similarly, for H2S, 2 hydrogens on the terminal position, sulfur in the center, and remaining electrons as lone pair. Total electrons will be 2 plus 6, 8. So 2, 4, 6 and 8. This is for H2S. Next is PH3. So 5 plus 3, 8 electrons, 2 between each of the atoms and 2 as lone pair. Silicon tetrachloride, total valence electrons will be 4 for silicon and 7 each for chlorine. So 7 into 4, 28 plus 4, 32. So we have placed 2, 4, 6, 8 as bond pair, 24 as lone pairs, distributing 6 each on each of the atom. Then nitrous acid, HNO2. So OH, in an acid, H is always attached to oxygen. So OH, then N, then O. So placing the electrons, we have to put a double bond here so that the octet is complete and the overall structure comes out as this structure. The next is nitric acid, HNO3. So for HNO3, you place nitrogen in the center, OH on one side and 2O on the other side. Now while placing the electrons, you see that nitrogen has to have 4 valencies, because of which it acquires a positive charge. Now similarly, the oxygen, when attached to nitrogen by a single bond, has taken 1 electron, has borrowed 1 electron on the whole, so it is having a negative charge. So overall the positive and negative neutralize each other and the molecule is neutral. Phosphoric acid, you place phosphorus in the center, 3 OH bonds and 1 oxygen. The oxygen shows double bond, others show single bond, and octet of each of the atoms is complete. C2H4, 2 carbons in the center, double bond between them, and 2 hydrogens on the each side of the carbon, 2 carbon atoms. Acetylene, C2H2. So for acetylene, 2 carbons in the center and hydrogens on the side. In order to complete the octet, we have to place 3 double bonds. 6 electrons are being shared. In case of nitrate ions, nitrogen in the center, 3 oxygens on the sides. One is showing double bond, others are showing single bonds, and overall there is a negative charge. So the oxygen atom having showing double bond has 4 electrons as lone pair. The oxygen showing single bond has 6 electrons as lone pair, and octet of each of the atoms is complete. Then carbonate ions, CO3, 2 negative. So placing 3 oxygens, you have to place a double bond in one of the oxygens and then complete the octet. As a result, this is the structure that results. For sulfate ions, sulfur in the center and 4 oxygens on the side. Then for hydronium ions, the oxygen atom is placed in the center, 3 hydrogens on the side, and a positive charge. For HClO4, you have to, this is an acid, so OH, 1 OH and 3 oxygens, a single bond and 6 electrons distributed in order to complete the octet. So these are the different Lewis structures for molecules.